So the focus of this talk is on writing really good JavaScript code. Code which embodies all of these properties here. Code which is testable, which is scalable, which is maintainable, but also intuitive, debuggable, and adaptable. Right? And I'm going to make the assumption that this is something that we all strive to do in our day-to-day basis, on a day-to-day basis when we're working on our web projects, right? We all should be working in a way whereby we want to be kind to our future self, right? So we should be writing code which solves today's problems in a way that's easy to change and is easily adapted in 6 months, a year, 2 years' time, right? So how can this be achieved? Well, I'm going to talk to you about things that have worked well for me personally, and I'm going to touch on things like unit testing and some of the less well-known benefits it has on your code base, and also about applying object-oriented principles and how that helps test, decouple, and promote reuse in your code base. And then the last part of the talk, I'm going to wrap up by sharing with you some tips and tricks to really kind of take your code to the next level. So hopefully by the end of the talk, you should all come away with some actionable takeaways that you can put into use in your own projects. But before I do that, I'm going to tell you a little bit about myself. So I'm Damian. Friend me on GitHub and Twitter. I'm a senior UI developer for Sage. Sage are known for being one of the largest ERP systems providers to small and medium-sized businesses in the world. I work on a product called Sage One. Sage One is an entry-level accounting and payroll solution for small businesses, right? And it's in building out this product it's been a fantastic learning experience for crafting code for longevity, right? And it forms the basis of a lot of the concepts that I'm going to talk to you about today. Now that product was released almost 2.5 years ago now, and in that time, it has become a success. It's tens of thousands of paying customers and many, many more on trial. So that product has had to scale and grow to adapt and accommodate that increase in demand. But being a global company, Sage want to replicate that success in other parts of the world using other development teams, right? And rather than reinventing the wheel, Sage identified the fact that a lot of the common things that we've put into place in the UK accounting and payroll solution, that in order to retain brand and consistency, right, that a lot of those things would be reused in other products. So it made no sense from like a resource point of view for other development teams in other parts of the world to go and reimplement those things. So rather than doing that, what we've done is that we've built out this kind of like what we call the Sage One platform. It is in itself many things, but the thing I'm going to talk to you about is the UI component aspect of that platform, right? So what that is that we've abstracted all of the visual UI components into a shared code base that's really, really rich, really solid, that can be wrote once and reused everywhere, right? And that really sort of springboards other development teams into writing their applications really, really fast and rapidly, right? So the benefits of this are fantastic, right? Think of it as kind of like a jQuery UI or Twitter Bootstrap for all things visual that's presented to the user, except good. So all of these things are being built with like maintainability and scalability and rethemability in mind. So right now, this is kind of the way things are and where Sage One platform lives in the entire ecosystem of apps. So it's like write once, reuse everywhere. And like I said, everything can be extended and rethemed really, really easily. And obviously, the countries just keep coming on board. So it's in building out that component library that I've had a lot of time to think about what constitutes to writing good JavaScript code. Is there like a key ingredient? Is there like a silver bullet, right? Can anyone answer that question? Before you jump in, practice is definitely given. No? Well, I'm... Huh? No. I'm going to go out on a limb and say unit testing is that silver bullet. You can all go to sleep now, by the way. Unit testing. All right, if you're still awake. So let that sink in, right? I'm just saying, just by virtue of unit testing your JavaScript code, your code is instantly going to become better, but not for the obvious reasons, right? We all know we should be testing our code, those of us who don't, right? We all know that the benefits of testing are to ensure the correctness of our code and are to ensure that we don't introduce any regression into our code bases. So when we're building out like feature C, we don't impact feature A, which was built like 2 months ago, right? But I'm saying in addition to those things, good code is a natural byproduct of unit testing, right? And if there's one thing that I've done as a developer to kind of round off my sort of skill set, I'm going to say that learning how to unit test your JavaScript code has really, really helped in that area, right? So the goal of my talk is to demonstrate to you and tell you how just by virtue of unit testing, your code is instantly going to become better, right? And that's because testing kind of forces you down a particular path. And it may not be nice initially, but you'll certainly reap the benefits. And I want you all to experience those benefits with me, right? And we're going to do that through a small example. Suppose we're trying to build out Twitter, right? Not all of Twitter, but just a small piece of it. So presume that example is creating a tweet, right? When a user wants to create a tweet, they interact with the form there in the top left-hand corner. They input their tweet and then they press save. And then what happens there is that there's an Ajax post. And then on the successful callback of that post, the tweet's added to the timeline, the tweet counter, updates, all that kind of stuff, right? You know, how would we achieve that sort of functionality normally? Well, here's a piece of code to achieve that. We're probably just bind a submit handler onto the form instance up there in the top left-hand corner. We'd store some vars, and then on the submit of that form, we'd stop the default action, right? And then we'd perform the Ajax post, and then on the callback of that successful post, presuming it is, we'll append that tweet to the timeline and reset the form, right? Pretty simple stuff. Generally, like, this is the way most people, or a lot of people in my experience, kind of write their code. It's kind of like the jQuery way of writing and expressing things, where it's really terse. It's a solution to the problem, but it's not the best, and I'm going to tell you as to why. How would we test that piece of code? I'm going to say we can't, and I'll tell you for why. There's just too much happening, right? We've got anonymous functions, we've got tight coupling to elements and things in the DOM, we're hitting the server, so we've got some network I/O, we've got doubly nested callbacks, and we've got HTML templating, right? So there's a lot of stuff happening there. And as soon as we say that something can't be tested, that should be an immediate code smell, right? It's a combination of all of these things that don't lend this code to being tested very well, right? And it's like I said, part of the problem is the way in which we normally write code. And I'm going to say that part of the issue is the fact is jQuery, right? It's the jQuery way of writing and expressing things. So don't get us wrong, jQuery's done a fantastic job of kind of like lowering the learning curve and being able to quickly pick up and write some JavaScript. It's like unopinionated in nature, and it doesn't enforce any structure or any like code organization or any code base. In fact, it actively promotes the use of anonymous callbacks, right? But the problem with this is that, in effect, what's going to happen is that maybe in 1 year's or 2 years' time, writing code in that manner, basically just creating a rod for your own back, because writing code in that way doesn't facilitate change, isn't maintainable, and it's tightly coupled to the DOM. It's tightly coupled to particular things on that page at that time. So what we should do is really leverage jQuery for what it's good at and just leave the rest. And those things are Ajax, event handling, and DOM manipulation. A smarter man than I once said, if something's hard to test, it's a good sign that you need to refactor your code. So if we go back to our Twitter example, I think we've established that the jQuery way isn't ideal and doesn't lend itself to testing very well, and that we really need to rethink this code. So I banged on about what's the wrong way about doing things. What's the right way? The right way to be able to express your code in a way that's testable is through something called objects, which you should all probably know and love. So testing kind of forces your hand into encapsulating all of your logic as objects, right? And they're the building blocks of good code, right? Because it allows us to unit test properties and methods on those objects in isolation, right? And because we've unit tested those small units of work, we can be sure when they're all on the page together that each of those are going to work independently. So we really ought to be leveraging objects to the max, right? This would be your second main takeaway from this talk in addition to testing. And the benefits this is going to have on your code base is immense. Object is reusable and it has state. It allows you to effectively break up your code into modules and classes, and from those things discern like a sensible file organization structure. I'm sure a lot of you have heard of things like Ember.js and Backbone.js, which are quite popular now for creating like single-page applications. Now, those applications leverage the power of objects a hell of a lot, right? And I'm going to say that I think that's part of the reason why they've been so successful, right? Because they're leveraging objects and enforcing you to go down this route of creating like an MVC pattern, right? To write out your single-page applications. And we want to leverage that also. So harness the power of objects and encapsulate all your code as objects. And you're definitely going to feel some massive benefits on your code. Because objects promote the single responsibility principle. So just by virtue of giving something a name, it's easy to adhere to like the single responsibility principle, ISRP. So if we were to call something form or dialogue, it makes it quite easy to make that distinction where your code should live, right? It makes it easy for that file to do one thing, to do it well. And if something doesn't feel like it fits in there, then it probably needs to be abstracted out into some other object, which can also be tested independently. And it promotes decoupling, and it gives you, as a developer, kind of an intuitive sense of what's happening. You can open a dialogue class or object or whatever, and you can just like read through the code. You can say, okay, yeah, that's good, I kind of understand what's going on here. And then that helps you build your mental model of how the code base is architected and how to leverage building out your applications using those things. So if we were to go back to our Twitter example, how would I write that and express that as code which leverages the power of objects? Well, the benefit of objects is that you can start to think about things in a higher level of abstraction, right? So when I see that form, I don't just say a user creating a tweet. All I see is a form that can be submitted via Ajax, hence the naming convention Ajax form. And the great thing is this can be unit tested, right? Because it's got state. We can create multiple instances of this. So if we want to reuse this elsewhere in our code base, we can, just to Ajax up a form. We've got name functions, so those things can also be tested independently. It promotes a single responsibility principle because it does one thing and one thing well. There's no coupling to IDs or anything in the DOM. All the configuration is passed in as part of an initialization of that object. And it promotes loose coupling because it's using things like a really lightweight pub sub mechanism there to promote the fact that a successful event has happened. And the great thing is other modules and classes and objects also on that page can listen out for that event and do their own thing, each of which can be unit tested independently. So like I said, this is really conducive to testing, writing your code in this way, and I highly recommend it. So if we were to use a Jasmine example, we could assert against things like properties, assert the fact that certain functions get called. So like, for example, here we've got a handler which tests the jQuery API to assert that a certain method has been called on the initialize, right? So it's really, really flexible, really powerful. And again, this promotes decoupling and a completely modular, reusable architecture of code. So hopefully by now, I kind of give you a good insight as to why testing is good and how the natural byproduct of testing is maintainable, reusable code if you do it the right way, and that's through the power of objects. And I suppose what I also want to do while I'm up here is kind of like lower the barrier a little bit at unit testing and dispelling a few myths, right? Because people say, oh, unit testing, you'll probably be spending all your time testing. You're not actually writing good code. You're not actually writing code with business value, right? So, a lot of people say, oh, how much time do you spend testing? Because when I started it, I spent like 70% of my time battling against the test framework or whatever. Well, someone else smarter than myself once said, is that I get paid for code that works, not for tests. So my philosophy is to test as little as possible to reach a given level of confidence. So I'm saying that if you spend about half your time testing, you're probably doing it wrong. Anywhere over half's wrong. You should probably spend maybe a third or less of your time testing. What should you be testing? Your public API, right? So by expressing all of your business logic through objects, what you're essentially creating there are a bunch of properties and methods that are publicly available unless you don't want them to, right? And this is something I kind of picked up through working in the Rails community. So if you notice back there on slide 4 or something, I showed you that our platform is built on top of Ruby on Rails, is that those guys only ever test their public API. They never ever test any of their private functionality, and that's because they test the behavior of something, like the end result, right? So that private functionality is being called in public methods. So we want to be calling those public methods we want to be calling those public methods in our tests, and then asserting the fact that a certain result has came out. So that's how you test your code. You should only ever be testing your public API. How do I test my jQuery? This is difficult, but I'd say just by testing jQuery's interface. Sometimes it's a little bit easier to be testing the end result, the end output, but I've found in my personal experience that testing jQuery's API to be less brittle and a lot more performant, mainly because jQuery in itself is fully tested library, right? So you've confidence that that's going to do what it says it should do, unless your mental model is wrong, unless you've constructed your code in a way that's just generally just wrong, right? So what you want to do is kind of like stub out any calls to jQuery and assert that those calls actually get called with certain arguments, right? And as a result, your code becomes less brittle. It's not really heavily tied to DOM or anything like that. And you can just assert that certain methods get called. So it's really nice and fast, really performant. So here's a quick example of that. So what we're doing here is that we're spying on jQuery's Ajax function, basically stubbing that out, and then we're passing in a simulated a submit event, right? And then what we can do is ensure that the regular form action is prevented, and then we can also assert that that Ajax call is being called with certain arguments. Pretty simple stuff. So I think we've established that by now that unit tests are a win, JS objects are a win, and that you should only ever test your public API. Right? So tests are fantastic as they guide you to writing better code. Remember that if you can't test something, you're probably doing it wrong. So I hope I've managed to demonstrate to you how encapsulating your code as objects is the way to achieving testable, maintainable, rock-solid JavaScript. And using properties and methods on those objects can take you a long way. So what next? So this is the part of the talk where I'm going to tell you a few kind of like tips and tricks for things we do different at Sage. And most of these things aren't really possible without encapsulating your code in objects. So it should reinforce my argument about objects, right? Now, don't get us wrong, all of these things aren't really groundbreaking, but it's like the collection of small wins that come together to form better code and give you real power as a developer. So we take quite an interesting approach to using data attributes. We leverage all of our app initialization from data attributes, right? And that's for a few reasons. So JavaScript engines themselves are really, really performant nowadays. So that's one reason. Also, there's been just so many times that we've had developers jump into views and remove classes and IDs, not realizing that actual functionality on that page is hinged off those things, right? So we want to mitigate that just by saying, all right, well, you can do that, but all of our code, all of our functionality, all of our client-side functionality is driven through data attributes, so you shouldn't be removing those at all. And then all we can do is use classes and IDs for styling, I suppose. Data attributes also promote configurability, so developers can pass down dynamic things from the server side and add those things as data attributes onto the view, and then the client side can pass those things out and do something interesting with them. So your control flow might be different based on the presence of a certain data attribute. So a bit like this. So kind of like going back to Ajax form thing, except we're encapsulating that as a form object, right? We're pulling out the fact that there is the presence of a data attribute called Ajax, right? And then we can do something else based on the presence of that. Lifecycle hooks are great as they promote decoupling and allows developers to tap into the lifecycle of something happening on the page. So if a form is submitted, on successful callback of that, a developer can write a callback, tapping into the lifecycle hooks which are projected from the application, and then do something based on that. So like, for example, if a new tweet's being created, you can append that to the timeline or update the tweet counter, and those things can just bind on to those lifecycle hooks. So this is kind of like a really lightweight pub sub mechanism, and it's something that Twitter Bootstrap does quite a bit. So like here, we've got an example of all of the lifecycle hooks that the Bootstrap dialog publishes to the page it's on when a dialog is hidden, when it's shown, and when it's closed. Wrap your interface to third-party plugins. So leveraging third-party code is great when it comes to obviously solving problems, right? So if we want to use like a charting library like d3.js or like a jQuery UI date picker, that's all well and good. But certain things happen, right, whereby the life of those plugins don't meet the requirements anymore. So they might be good at the time when you put them in, so like the jQuery date picker or whatever, right? But in 2 months' time, maybe that date picker doesn't give you the functionality you need when you present it with some new requirements, right? And the best way to go about doing this is kind of putting an interface in between that third-party plugin and your code base. And that way, the developers aren't ever tapping into the direct interface of that plugin. What that means is that you won't have to go through the code base and change everywhere where someone has like invoked a jQuery UI date picker, right? Because that would just be wrong. So by wrapping the interface, all you have to do is change the interface to your code. So developers don't have to actually do anything different, right? Because they're just calling that same interface every time. You can swap things out and no one's none of the wiser, but it allows you to solve problems better. So this is something that I've learned through experience. So here's an example of us. We're just extracting an object out of the jQuery UI date picker, and then developers are expected to use our show and hide functions, and then that means all we have to do, if for example, like the code, if that third-party plugin is abandoned or it doesn't meet any requirements anymore, all we have to do is just change this interface, so it's one place that we have to change. So it's really, really good. Leverage mixins. So mixins are something that are really popular in the Ruby community, and are basically ways of like mixing in properties and methods into a class so that class gets behavior. And it's great for ensuring like all the APIs are consistent. So here's a really quick and dirty way of achieving that. So here we've got a mixin for form inputs, and what we're doing is that we're augmenting text box, select, and checkbox with those two methods, and it makes it really, really easy to mix it in using jQuery's extend functionality. And then when someone creates an instance of text box or select or checkbox, they automatically get methods like .getValue or .setValue, right? Keep HTML out of your JavaScript. Use Mustache or Handlebars. That's all I really need to say about that. Private functionality and private scope. Like I said, really, really handy. So what you can do is that you can wrap all your stuff in a self-invoking function. and then within that, call private functionality, and then that means you don't have to actually test that at all. So what you're doing is that you're kind of limiting your exposure to testing and limiting the APIs that other developers can get access to by using and leveraging private functionality. And it also ensures things aren't put in the global scope by putting things in a closure like that, unless you specifically wanted to, hence the like export.form equals form. So I think that's everything from me. Has anybody got any questions?